Right, this is my favourite one, partly because I can now go back and start talking to you about another very, very famous Greek mathematician called Hippocrates. And although it's not Hippocrates that was the famous doctor, as in the Hippocratic Oath, this is a chap called Hippocrates of Chios. He explored this shape here. Now this shape here is called a lune, as in crescent moon, lunar. And what he tried to do is he tried to show that this area could be represented with the dimensions of a square. Because of course a lot of the ancient Greeks were really, really interested, can we square the circle? Can we work out dimensions of a square which will have exactly the same dimensions, as the area anyway, of a particular circle. Now, they eventually proved this in about 1880. You can't find this because pi is a transcendental number. Okay, so if you can't take the square root of it to get a nice number that they all worked with. So what we're going to do, obviously look at this, it's got rotational symmetry of order 5, and you've got these lovely lunes here, but although it looks like a spiral, these are actually arcs of particular circles. Okay? And what we're going to do is we're going to focus on those arcs. So I want to just introduce you to the problem called the quadrature of the lune. Now, what this means is, can we show that the area of this bit here is equal to the area of the triangle from A to C to O? Okay? Now this was a very famous problem in ancient Greece, and this chap Hippocrates of Chios came up with a brilliant, brilliant geometrical solution. Now I'm not going to do that with you because it'll take too long. What I will do over there is on the whiteboard I'm going to go through with you a really nice, neat solution that you could do with your students as soon as you've done the area of a circle, for example. Alright, you don't need any more information than that.
So is it geometrical proof, isn't it?
Or
is it just more like a demonstration?
All of the proofs that, that are in Euclid's, well, certainly in terms of the geometrical problems, yes, they were geometric proofs.
Yeah.
There are some sort of algebraic proofs, but it was very rudimentary algebra. Okay, because the idea of using an unknown, like x, for example, that wasn't used until the Arabic mathematicians, sort of 900 AD. Okay, so let me just turn the lights on a moment, and here we go. So in the words of Blue Peter, here's some I prepared earlier, and what we're trying to do is we're trying to show that this shape here is the same as the area of this shape here. Now what you find is you've got this shaded area. Now the shaded area is common to both of the shapes. So all I've really got to do to show that this lune is the same as that particular triangle is actually to show that this semicircle here has the same area as that quarter circle there, which is really neat. Okay, and that's what he did. Now then, algebraically, I don't know the dimensions of this circle, so very simply I'm just going to call it x. Now by Pythagoras' theorem, because this is a right angled triangle, this then will be, any ideas? What will be the length of the hypotenuse?
Square 2x.
Brilliant.
So x
What?
equals 2.
2, okay. This one will be the square root of 2x squared. Yeah? Yeah? So if we square root that, what do we get? Root 2x, brilliant. Okay, so this side here then is actually root 2 lots of x, fantastic. Now that length there AC is the same as this one. So therefore, if this is a semicircle, then the radius of this semicircle will be that distance divided by 2. Happy with that? So this is actually root 2 over 2 lots of x. Right, all we're going to do now is work out the area of this quarter circle and the area of that semicircle, and fingers crossed they're going to be the same. So here we go. Area of that quarter circle. Well, I keep emphasising quarter circles. There's a quarter of pi times the radius squared. Yeah? Now the radius is x, so it's going to be x squared. So it's a quarter pi x squared. Same with this one then. What's the area of this semicircle? Well, semicircle, so this area then is going to be a half of pi times this radius. Oh gosh, that's root 2 over 2x, all squared. So I now multiply through.
The same, yeah.
Root 2 over 2 squared becomes 2 over 4 x squared. And lo and behold, I get a quarter pi x squared, which is exactly the same thing. So therefore, by definition, we've shown that the area of the lune, so this strange looking shape here, it's almost counterintuitive, isn't it? That shape there is exactly the same as the area of that triangle. It's not something you necessarily would have thought about or even considered.